Hello guys, in this tutorial I will tell you how you can find a suitable dataset to do some work, to write a paper or to do a project, how to find a suitable dataset and then how you can find an, a set of helping codes so that you can get the guidance from that and then you can run it, replicate that code in the Anaconda. So let's start and find a suitable dataset. Let's go to kaggle.com. Here you will find on the left side you will find a panel and that there is a dataset tab. Click on dataset and okay, let's wait first. In this tab you will see different datasets which are available. You can click on any one. There are different datasets which are trending, some popular datasets. For example, there is dataset for COVID-19, stock exchange dataset, Olympic in Tokyo, and some other datasets. They have categorized it. I mean, if you want, you can just go above and click on uh, classification because we are doing the machine learning course. So let's find a dataset which is best, best, which need to classify some images or any text data. So here it shows that there are 2034 datasets available in this category. And you dig more. For example, there is a dataset. It's a large-scale fish dataset, and obviously you have to categorize. Okay, if you find a fish, you can say it. Okay, this type of fish belongs to this fish is name is this blah blah blah. So you can see that this dataset is 3 GB. So I will suggest you to download the dataset which has the minimum which requires minimum storage. For example, there is MusicNet dataset. It's obviously it is related to music, and you can see that there are some 992 files in it, and the dataset is of 22 GB. Similarly, there is X-ray chest X-ray dataset. It's of 11 GB, and if you go down, you can find many. So if I come here and you can see here that this dataset just contain one file and it's related to heart disease, and as we are in the classification category, so it means that in that dataset might be we have to classify the heart disease. So there might be several type of heart diseases, so we have to classify that. Okay, if the patient has these things, then it means he has this heart disease, and if he has some other parameters, attributes, then it means it has another kind of heart disease. So let's go and see what's in heart disease. You can see here it's just this data set is of just 3 kilobyte. So if you want to download this data set, you can download it, but if you click the download button, obviously you have to log it in first to Kaggle. So let's go and first see what the dataset is. So the dataset has just only one file, and that file is CASV file. It means comma separated file, and the file is like this. File has uh, several columns. There are 14 columns, different columns, and One column is containing the age of the patient, another column is containing the sex, whether it is male or female, and then chest pain type, what type of pain the patient has. They have categorized it to 1, 2, 3. So then there is a resting blood pressure column, and they have measured and recorded the blood pressure, and similarly there are other attributes. So each one is an attribute. This age is an attribute, sex is an attribute, then chest pain type is another attribute. But if you go, this is one instance, okay, because this is one sample, this belongs to one patient. So this is one sample, and that sample has several attributes. Each sample has several attributes. Similarly, if you go and you can see here, so there are 14 columns. Now let's download this dataset. I have extracted that file, and now let's open it. We can see the similar data in the Excel CSV file. So this is actually CSV file, that's why it is showing you like this. So there are several columns. I mean, they are separated by comma. This is age, sex, CP, rest blood pressure, call, FBS, rest ECG, and there are some other tests which are there. And there is also a target. Target is having a one column, and that column is named as target. It means the class label. It means that if the patient age was 63, his sex was 1 might be a male or female, they might have written it somewhere, and CP is the type of chest pain is 3, and blah blah, he has at rest he has a blood pressure or she has a blood pressure of 145, and the type of the disease was 1. Similarly, this has type disease was 1, 1, and if you go down, you can see here that this patient has different type of disease because they are labeled as 0. Okay, so I mean, might be he don't have a disease. 0 means don't have a disease. So as you see, in this data we have only two classes. Okay, one one class label is 0, another class label is 1. It means either the patient has a disease or either the patient does not have a disease. So we are classifying. We will classify using this data, and each row is a sample, is an instance, and each row has several values, and each value belongs to an attribute, and the last value is the class label. Okay. So this is our data set. I don't want to save it. Let's go back. Okay. So now we have seen it. You can also extend this one, and you can see the description. He has written it. The dataset contains 76 attributes. He has written wrong. There are 14 attributes, but all published experiments refer to using the subset of 14 of them. Okay. He said that actually dataset has 76 attributes, but we have only published 14 of them. The dataset is only one that has been used by Machine learning researchers to this day, the goal field referred to the presence of the heart disease in the patient. It is integer value from 1, it means no presence, to 4. So as we see in our data, in the data set which they have given, they have only one type of disease I think they have mentioned, but might be I am missing. So from 1 to 13, these are the attributes, and obviously the last column belongs to the target. Okay. So then you can see here there is a task tab, code tab, discussion tab, activity, and metadata. The good thing about Kaggle is if you don't have Anaconda, you can create your new notebook here and then you can start writing your code here. But I will suggest you to download the Anaconda and install it because it's easy and it will be good for you in the future. So now let's press on code section, code tab. It will show you all the code which people have written to solve this heart disease classification problem. So you can see that this person got the silver rating on his code, this person got bronze rating, and similarly bronze, bronze, bronze. So what you have to do, you can open any code. These are several codes which are actually solving the same problem. Let's open this code and see what he has done. So now you can see that he has actually given a good description about the data set also and how he is gonna do it. So he has made a table of content, details about the data set, importing libraries. He has given the steps which he will perform in his code. First he will import the libraries, then import the data set, then he will do some basic data exploration to understand the data. Then he will do some data processing, exploring the data analysis library and this kind of things. Then he will check whether there are missing values or not. What does missing values means? For example, let's see the data again. Here it is. Here it is. So you can see here that I mean there is age mentioned, sex is also mentioned, CP is also mentioned, and then test blood pressure. But for example, if a person forgot to write, or they did not check the blood pressure of that person at rest, then might be this value is missing. Okay. So this is called the missing values, where the attribute values are missing. So he will check whether some attribute, all the attributes has all the values of each instance or not, of each sample or not. Then he will find some correlations. Then he will separate dependent and independent features. Dependent and independent features. Dependent features mean which features which are depending on each other. I mean feature means attributes here which are depending on each other. And then he will split the data set. As I told you, machine learning, in the machine learning, while we are making the machine learning model, first we do the training part on some part of the data. We give it to the machine learning algorithm, and on that part of the data we train the algorithm. And then we, once the training is completed, then we give another part, unseen data, to the system to predict it. Okay, so there are two data sets. I mean, we can split it into training and testing. And he will build the models, and then he will evaluate the performance. Building the model means he will train the models on the training data set, and then he will do the performance evaluation by giving the uh, testing data set. So you can read the blog, his code and he has commented all the things. So I'm gonna just show you how you can do that. So here he is importing the library. So this is the first cell which he executed. You can just copy the cell link if you want, and you can embed a cell, or you can just copy the code like this. Copy. You can go to your Anaconda navigator, and from the Anaconda navigator you can launch the Jupyter lab. So this is mine. So I opened the Jupyter lab, and then I will create a notebook. So I created a notebook, and then you can name the notebook. You can rename it. I mean, from here by going to the file on the left panel, and then right click, and then you can rename that. You can also download that. You can make duplicate and other things. Okay, so let's paste the code here. Okay, Control V, you can paste it, and then let's run it. Okay, so you can see here that it's a static sign now. So it means the first line is still, first cell is still being executed. So it is still doing it. Matplotlib is building the font cache. This may take a moment. So anyhow, the first cell is being executed. Let's go back and see the rest of the code. So after importing the libraries, he is importing the dataset, and he is giving the path of that dataset. Okay. So let's go back and see what the problem is. It says the library does not found. Okay, so what you can do, you can go here. If there is no library found, either you can go back to the Anaconda. Here you can go to the environment, then you can go to the not installed, or select all, and here you can search the package which it is saying not installed, cannot found. So you can plotly, this is a package. Let's search it if we can found it here. So we couldn't found it. So the other option is you can go here, you can launch a new notebook, sorry, you can launch a console, or either you can go to terminal. Okay, I opened the terminal here already. So you can click the terminal and the terminal will open. So what you can do, let's try pip install plotly. Let's see if it installs with this command or not. So you can see here it started installing this package or module, you can say, or library, whatever. Okay, let's go back to the code meanwhile. So the next step is he is importing the library. He is importing the data. He is actually telling the compiler that okay, my data set is location is here. So what we have to do, we have already downloaded the data set. So I will just copy it and I will paste it to the same folder where I am executing my code. So let's go here. Inside here is no, not here. Sorry. Okay. Here is it. I'm gonna paste my code here. So now after installing, I run the code again and it's executed successfully. So now let's import the dataset. What is it? Yes, here is it. Okay. So I'm just removing this thing because my path is this one. Oh, so it gave me an error. As you see, it says no such file or directory exists. So actually, I gave the path wrong. I forgot, and this is the correct path. So either you can give the forward slash, you can replace it with the forward slash here, or here, and here also, and then here also. And now run it again, and it successfully executed because it has assigned the number to it. Okay, let's see the next. What he's doing, he's now doing the basic exploration. He's trying to understand what the data is. So what he will check the head of the data set. I mean, these are the heads of the data set. The shape of the data set. Shape means how many samples are there and how many attributes are there. So this data set is, you can say, this is the shape of the data set. Data types of every column, what type of data is in each column, and then this summary of the data set. So he is checking the head of the data set by data.head. So actually he imported the data here. Okay, he said that okay, he used PD library. He used the PD variable, and that PD is actually panda. Okay, this is the library module from where you using this module you can import the data set. So he gave it a variable name PD to that library, and then he said pd.read CSV file. So he is telling okay, please go and read the CSV file, and then we gave the name of that path and name of that CSV file, and once it read it, it assigns this file values to the data variable. So now we will check the head of that data. Let's execute this line. So this is the head of the data. So it's showing the top 5 column rows of that, and you can see here the values are 111, and these are the attributes, and those must be 13, and 1 is the target one, so those actually you can say 14. So 1 2 3 4 5 6 7 8 9 10 11 12 13, and the last one is the class label. So let's go and see what he is doing. So now he is saying that okay, he will take 5 samples from it. Okay, just to see what are those samples are. So go and paste it and run it. You can see those that there are 5 randomly selected samples. He picked it up. I mean, one sample he picked it from row 45th row. The other sample he picked it from 185th row. So this is how randomly he selected those samples just to see it. And then now he is checking the shape of the sample. I mean, how many attributes are there and how many uh, samples are in this data. So you can check this shape of that. So it says there are 303 samples and 14 attributes in each sample. So what's next? He is getting the info. In the Python, if you place a hash sign, it means those are the commented lines. So you can run it and you can see that okay, the memory usage is this one. These are the integer type values in 64. The old peak is actually the column name and attribute name, and it has float values. And you can see here that age has 303 values because there are 303 samples, and sex has also same, and same way each attribute has 303 values. So there are two type of data being used. One is float and the other one is integer. So this is actually you are just checking what type of data is it, how many samples are there, and blah blah blah. So what this line, this instruction will do, he has already described. The described method will help to see how data has been spread for numerical values. Okay, so now here you can, I mean, using this formula, data.describe and include all. Include all means is actually it will show the standard and mean deviation and the minimum value of that attribute and the maximum value of that attribute. So you can go also and you can run the same code. So you can see that age has 303 values, different values, and the mean of those values is 54.36. Standard deviation is 9 point something. Minimum value age is 29, and you can see here that this is the maximum value, and he has calculated some percentile of each, and similarly he has calculated for other also. So the minimum value is 0 for this one and the maximum value is 1 for the target label. Similarly, you can go and see the columns, how many columns and what are their names. So you can also run and see. So now he is doing some data processing. He is actually trying to explore the data. He will check some missing values. He will correlate the data. For that, he needs another library, or you can say another package or module, and that name is data prep. So you can install it. You just have to go to the terminal in the Anaconda. You don't have to open Anaconda. You can just go again to the Jupyter lab, go to the terminal, and then you can type, where is it? Yes, yes. You can type pip install data prep and enter, and it will install the data. It will install the package. So I have already installed, but if you want, if you don't have, you just have to go and install it. Let me go back to show you where is it. So you can just create a new file and here go to terminal, and then once you launch the terminal, it will open like this and you can type the command there. So you can install this. You don't have to write this exclamation mark. You just have to type pip install data prep and it will install it. Once it's installed, then you can explore the data. So now he is importing the package and he is saying that okay, from dataprep.eda import this library create report. So we will also repeat the same step. Let's go here and write it. You can just do all by one and execute, or you can just create lines and then let first copy it and then we will see it. Let's copy this one, then go back. Okay, that 2 lines is enough for right now. Click on this line, on this cell, and then execute it. So it's still processing and it gave me nothing till now. So it's still doing it because there are a lot of threads which are being executed in my notebook. It will take time. So it's finished. And now we will create a report, and into that report we will give the data, so it will automatically create some report for us. So you can see here that it's executing because there is a static sign here. Even if I write a code here and if I press the run button, first it will finish the execution of this one, then it will run the next cell. So here it has given us the overview and it says that there are number of variables are 14 and there are rows 33 rows. There is no missing value, there is no missing cell, and there is one duplicate row. It is duplicated percentage. It has calculated total size in memory and average row in the memory. So similarly you can see here that sex has constant length 1, CP has also constant length 1, and blah blah blah. So you can also see the overview, then you can go to the variables and you can check one by one that there is an age. You can see the data and it shows that approximately unique value is this one. There is no missing value in the age, and the infinite is obviously 0. There is no infinite value. Memory size is taking this one. The mean value of age is this. Minimum value is 29, maximum 67, and so on and so on. There is no negative value in the age, and this is how you can see that the age is distributed. Okay, so it starts from one person has 29 age, then there is another person and he has this much age, and you can see that it's going on and on. So it's showing the frequency. Okay, I mean 1% has just 29 age, then there are 2% who has almost, you can say 36, or they are under 33.8, 34. So there are 2%, and similarly here you can see how many persons are there. There are 19% who are in this category of the age. So similarly you can see the sex. There are just two sexes here, male and female obviously, and Uh, One type has almost 207 samples. I mean, 207% belong to this group of sex, and 98% belongs to 96, sorry, belongs to this group. And similarly, you can see the rest of the data. And he has find the correlation that, okay, I mean, this sex is dependent on the age, and you can find the values here that it is not dependent, they are not dependent, the sex and age has, I mean, they are not that much dependent. But here you can see that there is a correlation between this value and CP. So there is a positive correlation, and it's almost 0.3. Similarly, you can see here there is a negative value of the correlation between the old peak and the uh, slope. So you can find the correlations, you can see the missing values. So all have all the values, there is no missing value. So this is how you explode your data. Okay. And now let's separate dependent and independent feature. Let's run it, and you can see the indices of that. And now he's splitting the data set. What does splitting means? He's telling that, okay, this X train means the attribute for the training, X test means the attribute for the testing one, those values will come in that. Then there is Y train. Y train means the label of the training data, and then the labels of the testing data. And then he's splitting the data. He says that X and Y and training size is 75. 75% means I mean 75% of the total data will be given to the model for the training purposes, and it will select the you can say randomly. I mean, if you write random state and then you give some value, it will bring the randomness. Okay, so it will select, it will divide the data randomly. I mean, it will not take one from one class, from one label, and make it as a test data. No, it will pick randomly, and it will divide it into two categories. So let's run this one. So it's executed successfully. Let's go back, and now he is importing another library which is called standard scaler. It's actually just for pre-processing. We should also install it. Okay, so it's executed successfully. So now he is creating a standard scalar object to normalize the X train and test set features data. So what he is doing, actually you can see here that the values of our data, where I should go and show you. Okay, let's go over and see. For example, here these values are not normalized. I mean, where is it? These values are not normalized. So in order to normalize it, the scalar function will bring it into the between 0 to 1. So all the values will be normalized. So each attribute value will be less than 1 but greater than 0. So it will normalize it. So where were we? Yes, yeah. So once let's normalize the values. So our values are normalized now, and you can print some top 10 rows of your training dataset to see whether the values are normalized or not. So let's see the values. So here you can see that the values are normalized, and most of them, so it normalized between almost, you can see here that the range is going from -2 to 2 almost. So it depends on the spread of the data, how long your data is spread. So if it's spread it over a much greater values, then obviously the normalization will be depending on that. So now he want to build the model, and you can see here that you want to build a knife based model, linear model. Similarly, you want to do some KNN or some assembly or decision tree models. You want to build it, and for that we want to import these libraries. So let's import these libraries. These are actually the algorithms, and based on those algorithms he is building the model. So before building he needs those libraries. You want to build a logistic regression model. This is an algorithm also. Machine learning. You want to build a KNN classifier model. You want to build a random forest classifier. Similarly, decision tree. So all of these belongs to machine learning algorithm. So let's import these libraries. So it's import. The libraries are imported. And now let's build the classifier model. So let's build it. So he's saying that model.append, and he's giving the name of that imported library, and he is also giving the functions you can see here. So let's execute that, and we build different models. Okay. You can see here that it's an array, you can say, and each index has a separate model. The zeroth index has logistic regression model, then the other one is knife based, then the random forest, decision tree, and so on. So in the KNN model, he is defining the nearest neighbors because it needs to be defined. So as till now you don't know what are the nearest neighbors, so just leave it, just execute the code. So here he is building the models, and he is trying to train it. So you can see here that he is actually taking the zeroth index. He is printing the name of that model, then he is going to fit the model. Actually he is feeding the training data, he is feeding the attributes of each sample, and at the same time he is giving the label of each attribute. Okay, if the person has this, it means he has this disease, whether he has disease or not. The y value is containing yes or no. So he is building that model, then he is predicting the model with the new values, and the new values he is just in the new value when he is predicting, he is just giving the attributes. So the machine has to tell the label, machine has to tell the y value, which will be yes or no, 0 or 1. So after the prediction, now he is computing some errors and accuracy and this type of things, and you will learn these things in the course. So let's run this. Let's So once all this happen, then there is a for loop. So once the zeroth index, I mean the logistic regression model is trained, and then it did the perform the prediction. After then he is just showing off the accuracies and how much he predicted well or wrong or blah blah blah. Then first loop is finished, then it go back and take the second model, which is the knife base, and then he train that model, and then he try to predict by giving the unseen data, which is the testing data. So let's run this, and you can see here that the first model was logistic regression. The confusion matrix, I will tell you what the confusion matrix is later on in our coming lectures, but just for now I will tell you briefly. For example, if there is a label 24, and for example here you can see, yes, it's the same confusion matrix. So if there was label 0, it has to be, I mean the machine, for example, if there were how many labels, okay, so for example if there were the data which were given to the machine for the prediction, and there were almost 24 plus 9 is 33, so there were 33 data samples which patients who don't have the disease. So out of 23 you can say that the machine predicted 24 well, right, I mean you can see here, because there is 0, there is 0, it means the machine has, these are the predicted value you can say, and this one is the actual value you can say, okay. Or vice versa, because he did not label it, so I cannot judge what was the actual values of that. Anyhow, so he predicted the labels wrong here. For example, the actual value should be 0, but the predicted value is 1 by the machine. The predicted value is the 1. So 9 patients this model predicted wrongly. He said that they have a disease, but actually they don't have a disease. Similarly, here you can see here the actual value should be 1, and the machine predicted 39. For the 39 patients, he predicted 1. So there was no error for 39 patients, but for the 4 patients, the machine said that they don't have a disease, but actually there was a disease. Okay. So this is how it is. These are some measuring uh, performance measures, which are actually precision, recall, F1 score, and accuracy. Accuracy means how many he predicted right. So overall he predicted 83%. This model predicted right. Similarly, the next model is the knife base. You can see here it also predicted the non-patient, I mean non-disease patient, right, 24, and similarly he did 9 wrong classifications for label 0 and 4 wrong classifications for level 1, but 39 was predicted rightly. So the accuracy is almost same, 83%. Here you can see the accuracy is 80%. Yes. And for the decision tree, the accuracy is 79%. And similarly for KNN, the accuracy is 82%. So the best accuracy is gained by, you can say, knife base and logistic regression. So let's go back and see if he has done something else. So that's it. That's how you can go to the Kaggle. You can find a data set. You can see the code and you can run that code, and later on you can play with that code. For example, what you can do. For example, where did he? Yes. Here he splitted the data set. 75% of the data is used for the training and 25% of the data is used for the testing. So what you can do, you can just split this, change the value of this. I mean 60% of the data will be used for the training and 40% of data will be used for the testing. So then again now You can run that code again, and then you can see what are the results. This is how you can play. Okay guys, if you have any questions, you can ask me anytime, WhatsApp or email. I hope your confusions is removed, and now you can go to Kaggle. You can find a suitable dataset. I will suggest you to start with the normal dataset. Don't download the big dataset, otherwise when you will train the model, it will take hours and hours and your computer might crash. So just go with the dataset which is the minimal one and see how the people implemented the code there. Run the same code on your machine and try to play with it. See you guys.